All right, well, here we go. We're right now at 12 noon. So we're going to go ahead and let the rest of the folks in, and we're just going to go ahead and get started. So folks, welcome to another Lunch and Learn today. I'm really excited that we're going to be going through some of these different LiDAR sensor systems. There's quite a difference between all the different types of LiDAR that are out there. Brady's going to take us through some of the GeoQ LiDAR systems and talk a little bit about how they work. So Brady, we're just going to turn it straight over to you. The floor is yours, sir.
Thank you very much, Douglas, and thank you everybody for joining our Lunch and Learn today. I'm going to keep my hands off my table. I just saw some wiggling, so I apologize about that. So we're going to be talking about the TrueView system, specifically the 435, the 515, and 660, which are really the start system, and a mid-level system, and more of a higher-end system. While there are many other systems available, these are not the only options. These, I feel, depict the most difference between each of the different types of sensors for their price. So we certainly want to go over that information. For many of you who've been on some of these before, my name is Brady Reisch. I am the VDC reality capture specialist here at Kuker-Ranken, and LiDAR is my job and my passion. So I'm really excited to share some stuff with you guys. So let's really just jump right on into it here. So we have several different systems. While the first two might look very similar, they are different. And we'll talk about what some of those differences are. And then the third system coming up as the 660. Why do we use LiDAR, right? What are we trying to gather? We ultimately are trying to gather things for volumetrics, for getting DSMs or digital surface models, digital terrain models, DTMs, surfaces, get other information so that we can create topography, contours, and things like that. But where we have to start is a point cloud. So the point cloud, as you can see on the right-hand side with a little video that's playing, that each individual point has its own XYZ value, which means that we have three-dimensional objects using points in order to depict those different objects. So we're using the aerial systems, for example, outside of buildings to get the exterior of the building, for different land mass areas to penetrate through vegetation, which we'll certainly talk about. And there are also other options to scan interior as well. Well, that's not the focus of this Lunch and Learn. If you'd like to learn a little bit more about that, certainly reach out and let us know, because we can combine interior and exterior to create a full, comprehensive, and a full point cloud from inside to out. So ultimately, each of those points with an XYZ value gives us that three-dimensional form. And that's why we're really using these LiDAR systems. So another piece that we really need to preface before we start talking about the sensors in particular is precision versus accuracy. You can certainly check out the Kuker-Ranken blog, and we have more information on that. We also have some mapping guides and some information about LiDAR specifically. But ultimately, what it results in is if you have a target and you are trying to put a hole in that target, high precision means that you have a really close group, but you're not very accurate because you're trying to aim for the center of that target. When we have high precision and high accuracy, we're in the center and we're very close grouping. If we have low precision and low accuracy, we're kind of all over the place. And if we have low precision and high accuracy, we're towards the center of the target, but we're not grouped really well together. So ultimately, for all of our projects, we want to have high precision and high accuracy, and this is where the GeoQ sensors come into play. So the first one we're going to be talking about is the TrueView 435 system. This is a Hsai Pandar XT sensor that is constantly going around, so that black lens cover on the front that kind of goes around in a circle. So there's an interior LiDAR that's scanning at all times. Now that scanning system uses 16 beams in order to scan, and we require 2 returns to create a point. So it's constantly going out as the drone is flying, touches something, comes back into the sensor, and it says, hey, I have 1 return. I need another one in order to create a point on the point cloud. So this is just to reduce any extra noise or other things that might come back into the sensor. Different reflective material kind of changes that as well. So it requires 2 returns coming into it. So the effective range that has been tested out by the manufacturer is right at about 80 meters with about 20% reflectivity. Now, when we're talking about LiDAR, we're not necessarily talking about the colors, although colors do have an effect on the reflectivity. What we're looking for is it shiny? Is it flat? Is it eggshell colored? So we're trying to get more information to see how much of that light comes back to us. So as an example, if you're flying over water, it's extremely reflective. There's lots of other light that comes on, bounces around, and scatters, which means we have little accuracy over moving or shiny objects like that. If we're over the top of dirt or trees, they're mostly a matte color for a lot of it, which means that it touches that piece and then comes back into the sensor. It doesn't scatter everywhere else. So when we talked about reflectivity, that's why it's extremely important for LiDAR. So with the 435 system, we are looking at a better than 5 centimeter, basically a residual or error overall for your point cloud, which is actually really good. Now, 5 centimeters, what I will say is most of the GeoQ products, they do under promise what you'll actually get. So in my experience with the 435, we usually sit between about 3 to 3.5 centimeters as the error. But GeoQ likes to be conservative and not overpromise something that you may not be able to achieve. So I consistently get less than what the manufacturer specs out for a lot of these sensors, which is fantastic. This also has a 1-inch mechanical shutter with a 20 megapixel RGB camera. So it's taking image. Now, what's important to remember is when we're shooting LiDAR for all of these sensors, the idea is we are scanning using the laser system. We're not using the images for photogrammetry. The images are really only to colorize the point cloud, to give us color so we can see what is happening. That being said, one of the other large benefits for a lot of the LiDAR systems is we can fly in the middle of the night. We don't have to have color or light because a laser doesn't care. It's touching something, comes back and registers that point in the sensor. What does change is if we need colorization to see that the tree is green or that the asphalt is black or that the car is blue, then we do need the colorization of the RGB camera in tandem with those points in order to register that information. So really the 435 system is a great option for open areas with lower vegetation. This is great for construction and architects alike to scan the information and get a lot of information and usable data in order to make educated decisions. So that would be my suggestion for the 435 system. And this is more of a starting system, so it's on the lower end of the pricing structure. Now we get into the TrueView 515 system. This is a side pandar, so it's the same manufacturer LiDAR system puck on the front of this unit, but this is the XT32. So this actually has 32 beams, so it's sending out a whole bunch of lasers at the same time, and this still requires 2 returns. So again, we're getting rid of all the extra noise. If something else happens, we want to get rid of any extra fluff just in case. And when we pull up some data sets, you'll see some of the extra error that is inherent with some of these systems or even any LiDAR system. So this also, again, is 80 meters at a 20% reflectivity. Better than 5 centimeters is your error. Usually with the 515, we're between 2 to about 3 centimeters, so we're slightly better than the 435 system. And this has dual mechanical shutter cameras. So instead of a single camera looking down, we have 2 of them at opposing angles, one to port, one to the starboard, in order to capture detail. And this allows us, when we process our data, if you imagine there's a triangle, and at the tip of the triangle is where the drone is, we're scanning this entire area. What happens is our area that we're scanning is wider, and if you have a single image, it shrinks that beam down, which means on the sides we have a lot of black uncovered area, where it just means we're not colorizing that point cloud. So what we do is there's two cameras on here in order to bring that width back out to have a full coverage of where the LiDAR or the optimal LiDAR scanning is located as it touches the ground. So this one is, in my opinion, probably the best bang for your buck for medium to higher vegetation areas for penetration. This one is dubbed internally as the Vegemite because of its performance. It's just phenomenal. So this one is perfect for surveyors who go out and have lots of vegetation they need to cut through to get to the meat of the data that they need to get into. Or also for municipalities, whether that's state, or sorry, just different types of cities, if there's surveying departments for code enforcement, things like that. This one is fantastic. Then we move into the big dogs, right? The big daddy, and this is where the price start getting much higher. So this is a Regal Minivux 3 UAV system on the 660 TrueView. This one is really powerful. It has many more scans. So there's no listed information about how many beams we have, but we have over 100 scans per second with 5 returns. So what we're requiring is these last two, using the side panels, we've required 2 different returns in order to register a point. Now we can go up to 5, and this is modulated, so you can change and decide, yeah, I only want 3 returns, or I need 5 returns, depending on the conditions. So there's a lot of customization that goes into this system. Optimally, about 100 meters, so we're going 20 meters higher in order to gain the same efficiency that we do with the previous systems, which means we can fly further. You just have to have a bigger aircraft to carry a bigger payload. So again, better than a 2.5 centimeter residual error. And typically with the 660, I've seen sub 1 centimeter if you do it correctly, and depending on speed and a lot of environmental things. But you can certainly get it down below the manufacturer's claim to that 2.5 residual. And then this also has triple Sony cameras. This can also be changed out for even higher end Sony cameras as well, but it's got 3 of them. So instead of one sticking straight down, or the 2 looking port and starboard, we have a third one that looks down, and you also have port and starboard looking in either direction, which gives us even more information. This system is also NDAA compliant and is fantastic for any extreme vegetation penetration, which is something that a lot of large survey companies, Department of Transportations, or even governmental use would be using these types of systems. So enough about ranting on some of the sensors here. We're going to quickly cover how we're processing the data, and then we'll jump into the actual data itself. We'll pull up a couple examples. So in order to process all this data, all these sensors go in through a centralized processing program, which is called LP360. This allows us to process any of the TrueView sensors, and actually the DJI sensors as well, any photogrammetry from Autel, or from Maptek, or from Inspired Flight. There's lots of different ways that we can process this information, but LP360 is a centralized piece that is agnostic to most brands. So you can throw anything you want at it in order to process your point cloud and gather information. This is desktop processing. And what we want to remember is, as we process this data, photogrammetry would take much longer because we're stitching it together and extracting. LiDAR, we get it very, very quickly. So if you're using the LiDAR systems through LP360, it is a very fast turnaround in order to receive your data, which means you can make a better, more educated decision on certain things, and ultimately create more revenue for your company. So with that being said, and I would ask everyone to put their hands up, but I already know your hands are already up. Let's look at the data, right? Who wants to see it? So let's jump in here. We have a comparison set up. I will preface this by saying everything has been processed through LP360. We create a point cloud, which is 3-dimensional information. And then we're taking all this information and putting it into Leica 3DR systems. So this is just because it's very familiar, it's easy to use, it's easy to manipulate with much more points visible at the same time. And to be honest, it comes through really great over these types of calls. So with that being said, what we have on the screen right now, on the left-hand side, you can see I have the 435 system selected. So this is all the data that's been processed. I've done a few things to help colorize to give it a little bit different feel and a pop for you so you can understand what we've done here. We have classified these
Brady, we're still seeing
sensors.
we're still seeing the 360 slide.
Oh, okay. Thank you so much. I apologize about that. Let me pull that up.
There we go.
Screen share should be sharing. Is that better?
That's better.
Wonderful. Thank you for that catch, Douglas. So what we're seeing here is we have the 435 system, which is the first sensor that we want to show you. Underneath, we have this kind of teal bluish color that has been classified as our ground system. And then we have unclassified, which is anything that's not ground. And then there's a third classification, which is extra noise on top of that. And what I specifically want to show first, if we rotate kind of down to the side here, this is all in 3 dimensions. Let's go ahead and turn on our noise from the 435. Yes, these are things we can clean up. Yes, there are ways that we can clean or process this information without having the additional noise. But I want to show you what the difference is between the systems as default without doing much manipulation at all. So I've changed kind of those point sizes to be really big yellow balls here to show you this is all the noise. The green is mostly vegetation. Of course, some power lines in there as well. And then the blue is for that ground classification. But we can see there is significant noise using these types of systems. And again, we can clean it out. I just haven't done it because I want to prove a point. As raw as possible, this is kind of the data that we're receiving from the 435 where it is fairly noisy. Now, with that being said, if we come in, we can certainly turn off our noise. We can see we've got 3-dimensional data here. We've got all the trees on top and the blue underneath. I'm sorry, I made a selection there. If we rotate underneath, this is the best way that I like to look at data for holes inside of vegetation, which is why I specifically changed the colorization. So we can look at this data. We have some information underneath these trees, and they're very thick forested area here in this little section of land. So I would expect that we would have holes in here. However, if we were to use photogrammetry, we would not get anything on the ground. So with 435, I'm fairly impressed on how much we're actually able to see underneath. So we can start creating our models to then go into contours to whatever deliverable we need to for our customers. Let's rotate to the top here and let's go to the next example, which is going to be the 515 data. It's taken my computer just a moment to turn on all of the layers here. There we go. And I apologize. Let me change this color to a real color as well. So the purple now is the information we gathered from the 515 on the ground, so our surface model, the surface classification for our point cloud. Then we also have what's labeled as unclassified as everything else. And then we also have a noise. So let's do the same thing we did with the 435 is rotate down. We're going to turn on our noise and see with the Hesai patterns, we're still receiving some of that noise. And again, this can be worked out during the processing. This can be worked out once you have your finalized point cloud and start removing or obscuring some of those points. But I wanted to show you what came out of the sensor, right? We're not removing anything because I want you to see everything that's on here. So let's go ahead and just turn that off so they're not so distracting. And we're going to rotate underneath just like we did with the 435 data. And we have better coverage. And sorry, when I move the mouse around, sometimes it takes a second to load in the point cloud. I think it should be up by now. We have more coverage than we did with the 435. So again, as a higher end system, we're able to penetrate and get more information. And this is really personally the bang for the buck that I say, where it is a fantastic trade-off between the price and the results that you get out of the back end. So just incredible with the 515 data. And while I am changing this out to show you now the higher end 660 side of it using the Regal sensors, what I want you to keep in mind is all of these sensors can be mounted on many different payload or many different aircraft systems. So it doesn't just have to be one manufacturer or the other. They can go onto many different types of aircraft themselves. Let's go ahead and turn off our 515 and get into our 660 data. And now we have like a darker green and the lighter green for all of our trees. So we actually have more information with this one because we have more beams that are getting sent out, more returns that are being generated. And if we look under, let's look at our noise first. And this time I have these set as white. Let's change that to yellow so it stands out. And we'll make that really big points. So we have some high and some low. What I'd like to say here is there's a reason why sometimes they're higher and sometimes they're lower. When we hit things like standing water, trees, windshields, any reflective surface, it scatters. So maybe it scatters and hits something else that's reflective and then shoots down below our point cloud. So there are reasons why you see it up and below, but the point is we have very little extra noise compared to the other two sensors. So this is where, again, that price goes up, but you get a much better result. And this is where we're getting below that 2.5 centimeter error. So let's turn that off. Let's look underneath of this aircraft, or I'm sorry, underneath of the point cloud here. And we have even more coverage. So the 660 data gives us more detail. Again, there's still going to be holes depending on what type of vegetation there is, but we are receiving more and more and more information the higher that we end up stepping up that chain. So we are able to process this information, and what I'd like to show you is since processing this information, we have the LAS. I have gone ahead to create a mesh as well through our system. And this is only on the 660 data. There is one hole when I was doing some manipulation, and when I reprocessed, I removed a point, and that's from user error. It's not from processing this data, but from myself. But we can look at how clean this information is and what we're getting out of our as a result from this point cloud. So we have a point cloud. We then strip all the trees, everything else out of it, anything that's not ground surface. We create a tin model or a mesh. And then certainly from a mesh, very simply select the mesh, select our contour lines, give it a value, whatever we'd like. Currently it's set to 1 meter. Let's set that at maybe 1 foot. So we'll do 0.3 meters. We'll preview and hit OK. And there's our contour lines. And these are 3-dimensional contour lines, just like that. So if we have a customer who needs it very rapidly, very fast, this is where LiDAR comes into play. If you have something with a lot of vegetation, this is where LiDAR has a huge benefit over photogrammetry. So if we have this type of a system, let's just turn on our unclassified data for the 660, which means all of the trees and power lines and everything on top. This is what we're receiving is that surface underneath. Not only that, with LiDAR, it's very easy to use different pieces for power line inspections and things like that. Let's turn on our power lines here, and let's turn off our point cloud, and you will see we've done an automatic extraction for these power lines. So for a lot of public utilities, departments, or electrical departments, utility companies, this is a fantastic way in order to pull up data and then do intrusion to understand if maybe the vegetation is overgrown and now it's coming into the power line. That's a hazard. We need to take care of that as quickly as possible. So this allows you to do your routine maintenance and inspections very, very rapidly with the systems. So with that, I'd like to go ahead and open it up if anybody has any additional questions and go from there.
No questions have come in just yet, Brady, but we're monitoring the chat there. So if anybody from the Facebook side or the group side. One thing is in your presentation, you mentioned a tin display. Can you explain what a tin is for folks, the triangulated irregular?
Sure. So the tin system is really just triangles in between all those individual points in the point cloud. So we're creating a a blanket over the top. So the tin is just really a reference to creating something that is watertight. So if we were to pour water on it, does water get through it? No. If we were to put water on top of a point cloud, would water come through? Yes. So we're just kind of filling in all those gaps with triangles to build it up, and then we tell it how smooth to make those triangles. So looks like we have a few additional questions. Do you have a surface comparison between the different cameras? I do not have the different surfaces, but we can certainly go through that and get you some additional information, Keith. So if you want to see specific sensors, I can get it processed and send it to you after the lunch and learn, so that's no problem. And what airframe was used? So these are different airframes that were used. I believe there was an M300 that was used. And I think there was an inspired flight that was also used for these the capture of these specific pieces. But again, the LiDAR sensor doesn't matter which airframe it's attached to, as long as the airframe is capable of carrying that system. Most of these LiDAR pieces will scan regardless if they're connected to a drone. So if you just suspend it underneath something, if you technically suspended it under a helicopter, you basically launch and it's automatically going to go through and scan, right? You're automatically going to get some of that information. And when you land, there's a proximity that usually defaults to 25 meters that it will turn off or stop the scanning process. That's very easy to get into. So you can use any heavy lift aircraft that will be able to carry that system. So MSRP, we're looking anywhere from, I'll say around 45,000 for the sensor, upwards of, you can go certainly much higher than the 660 side of it, but we're looking at somewhere around the, I believe it's 175, right around the 200 mark for when you start getting into the regal sensors. But if you'd like a direct quote, certainly let us know, and we're happy to work through if you already have aircraft or if we need to get that quoted out to you as well and get a full complete package. And that's what Kuker-Ranken does. We want to make sure that we give you all the information and you the abilities and the tools and the software to process anything you need for your customers.
Yeah, Brady, I'm just going to real quick throw up the image of the new Easy One from Microdrone that's got that sensor down on the bottom of it. So if folks have an idea of what the so as Brady mentioned, the M300, the Inspired Flight 1200, and then the Microdrone Easy One, which is a brand new platform just now coming to market. So this is the Easy One flying over an open pit mine. But that's what that looks like with that particular package that's on there. Looks like you got a question about altitude there, Brady. Does 240 give you enough altitude?
Yes, so 80 meters is the ideal altitude to fly most of the Pandar systems, and that it doesn't mean that you couldn't fly higher if you wanted to, but just be aware you're going to lose resolution as you do that. So there's an optimal and efficient height to do it. So 80 meters is the suggested location. If you go lower, you want to fly slower to gather more details. If you have vegetative areas, yeah, you might drop down your altitude and go a lot slower to capture more data. If you're out in the middle of the desert, like most, some of us live out in Vegas, 20% overlap and go, as fast as you can go because you don't need to penetrate through the canopy. So it's all situational, depending on what you need and what your client needs and the resolution you would require out of that.
Low and slow if there's a lot of trees. Mm-hmm. And you can fly high and fast if there's not. Well, Brady, that gets us to the end of our time here. I do want to let folks know if you will be attending the Commercial UAV Expo in Las Vegas next month. I believe it's September 6th, 7th, and 8th, I think, if I've got the dates right. Sure enough, we're looking at the 5th, 6th, and 7th, of September at the Commercial UAV Expo. You will have opportunity to see these sensors fly in a live flight environment. We are promoting a nighttime crime scene investigation with a mock homicide, flying in the dark using these LiDAR systems, as well as the photogrammetry aspects of these systems to demonstrate what they can do. So at this point, it's expected that we'll be flying Autel, Inspired Flight, and the Microdrone Easy One platforms on this mock homicide homicide scene. So if you have opportunity to come out and see that particular flight take place, you'll be able to see these LiDAR processes happening in real time. And that'll give you a huge idea of the difference between the speed of photogrammetry and the speed of LiDAR. That's one of the things we're most excited to show and share with folks. Well, Brady, I think you did another outstanding job in being able to show some of these different LiDAR data sets. Folks, you've got Brady's email in the chat box there. If you've got questions, please feel free to reach out to either Brady or myself, and we'll be thrilled to answer your questions. And we can send you data sets. We'll just need to know what kind of software you're going to use to process, so we can help you work through that. But we do have raw data sets that are available that we can share out in most instances. Folks, thanks again. We know your time's valuable. We appreciate you spending your lunch hour with us, or half hour of your lunch with us here at Kuker-Ranken. And we look forward to seeing you next week at our next Lunch and Learn with Kyler Gould. Until then, be safe, everyone.